This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. The questions posed in this podcast series all come from automation technology users across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the topic for this podcast is understanding the different industrial networking topology types. And joining me for this podcast is Michael Bowne, Executive Director of PI North America, the organization formerly known as the Fieldbus Trade Organization. The name change occurred a few years ago to better reflect the organization's affiliation with the umbrella organization, Profibus and Profinet International, which is the Fieldbus organization responsible for, as its name implies, both Profibus and Profinet industrial network technologies. So, Michael, let's begin at the beginning, as they say, and start with an explanation of just what a topology is in terms of industrial networks.
Okay, Dave. In general, a topology is the layout of the network and how your devices are connected to each other. This representation can be done visually first ahead of time, so that you're looking at how your devices are laid out and where you want those connections to be made, and then those abstractions can then be brought to the physical world and how you link those devices together, and that eventually is what becomes your topology. And not so much a physical representation of the network, so where those devices are, but really a representation of the network, of the links between the devices on the network.
And is this, just to clarify, is this topology, is this something that's specific to industrial networks, or is this terminology is applied to network, computing networks of any type?
Oh, absolutely. It's a generic term to describe any kind of network that could be done. I mean, it doesn't even have to be done in networking. You might have heard of social networks. So, something like Facebook. Actually, they have a topology too, and the nodes and edges and things that they have to connect people in a social network could be used. Topology could be used to describe that. Just in our case, we use it obviously for industrial networks, but certainly could be used to describe commercial networks as well.
All right, so looking at the application of these technologies to industrial networks, how do they apply to Fieldbus or the Ethernet versions of the Fieldbus or wireless networks? Are there differences between the two of which ones are more appropriate for some than others, or a mix of them all? How does that work?
Yeah, that's the key question, and I think if we go back to how we started talking about your introduction, starting with Profibus and then moving to Profinet, I think we'll just talk generically about field buses and then also generically about industrial Ethernet, so that we're not confusing the two with respect to the protocols. So, as far as field bus is concerned, the most common topology that we see used is a what's known as a line configuration. And there are a couple of different topology types that are out there. One of them is called a star, which we'll get into a little bit later. And then there's a line configuration, and then you have something called like a tree or a chicken foot, some people call it, which is a combination of the two. But in a line configuration, the topology means that each device is connected to the next device in a, you guessed it, line. And so you typically find this in serial field buses, digital field buses based on physical layers like RS-232 or RS-485, like Profibus is, because that's how the networks and how the connections are made. Is you link them one to the next, and then you end up with a line. Not to say that a star topology can't be used in a field bus. It's just not really as common because of the physical layer restrictions on the serial networks like RS-232 and RS-485. So from a Fieldbus perspective, that's most likely what you're going to find in your industrial network is a line topology. In industrial Ethernet or Ethernet networks, uh, whether they're in your office or whether they're on your plant floor, as long as they're using standard unmodified Ethernet, you'll find not only line configurations as a topology, but you also find star topologies, and a star happens typically, let's say, inside of a cabinet. When you have a lot of devices close together, it doesn't really make much sense to go from one device to the next, where you can just plug it into maybe a 4-port or 8-port or 16-port or some sort of multi-port switch on the industrial Ethernet, and then from the switch to each individual device, and that creates your star. Now, just to clarify here, even though I did say that in Ethernet networks you have line configurations, in reality, when you have a line in an Ethernet network, actually on that device is really a 2-port switch. So the Ethernet packets are coming into that device, there's a 2-port switch, and then they're going out a different port on the device to the next device in the line, let's say, which is a little bit different from field buses, where with field buses, you only have one port on the device, and then the next in the line piggybacks off that first port. So just a little bit of a clarification there. And then, like I said before, you can set these up in different arrangements such that lines can connect to stars in Ethernet. We're talking about now. Lines can connect to stars and so on and so forth, and all the different ways are possible. There is one more thing to consider, and that's the topology known as a ring. And in a ring topology, the reason you do that, and by the way, we should just say here that if you're using Ethernet, don't start connecting your devices in a ring without doing some sort of management, because then you can have Ethernet packets going in circles forever, using up bandwidth and things like that. But there's another topology known as a ring where you do that for redundancy's sake, so that if a wire is cut on one section, you still have connection to your network through the other part of the ring. And so between those three, um, line, star, and ring, you kind of have your major possibilities as far as topology is concerned with physical wires. Now, you mentioned wireless, and that's a whole different ball
Mm-hmm.
game as compared to wired networks. There are all different kinds of wireless topologies. You can have roaming, where you're moving from one wireless access point to another access point, or point to point over wireless, or point to multi-point over wireless. A lot of different things are possible. But I think, at least today, what we see in the market is most people are using wired technologies for their networks, for their industrial networks, and wireless really only sparingly, maybe in something like a rotating machinery or something like an automated guided vehicle or places like this. So wireless isn't super prevalent yet. So I think, at least for the bulk of manufacturers out there, they're using wired technologies and therefore wired topologies.
Okay. And is that the case, Michael, with the you preference for the wired? I know historically it was just for consistency's sake, and because wireless, the dropouts with wireless is something that just couldn't be tolerated in an industrial environment. Is that still the case, or have other reasons cropped up as a reason for reliance on more wired connections?
It's not only to do with, that's a good question. It's not only to do with the reliability of wireless networks, it also has to do with the speed and determinism. When
Mm.
you run an industrial network over wireless, eventually at some point you're going to have to do a media change from the wireless medium back to a wired media, and that can take time. Or maybe you want to encrypt your wireless connection in your industrial network. Well, those packets need to be decrypted on the other end, which can also take time. And so in industrial networks where speed and determinism are absolutely paramount, that's the whole reason we have industrial Ethernet protocols in the first place. That's where those factors are paramount. That's one of the main limiting factors for wireless. That being said, it's really amazing the advances that are being made in wireless. Particularly in 802.11, which is the IEEE standard for Wi-Fi. Just a few years ago, you had only had 802.11a, and now you have B, C, G, and so on and so forth. And so the IEEE has done a really, really good job of updating 802.11 to add bandwidth and add range and all of these different features to wireless. And so I think maybe somewhere down the line, wireless will get better where it can be installed more frequently, but I don't see it replacing wired Ethernet anytime soon, particularly for the speed and bandwidth reasons.
Just to back up a minute, when you were talking about the different types of topologies, the star, the line, the ring, you also mentioned a tree or chicken foot. Can you describe that? Is that, you didn't go into detail about that? Is that just something not used often in industrial networking, or is it just the others are more common?
Yeah, I think it might be just a terminology issue. What I mean by that is if you take a, a number of switches and you connect them together, so you've got a sort of a cascade of switches. So it ends up looking like a family tree, and so that's where that comes from. So if you have maybe a switch with a couple uh, wires going in, and then one coming out to another switch further down the line, and then three or four going out to another switch down the line. And again, how you draw that, you could draw that as lines and stars, but when a lot of people are drawing up their networks, the way they do it is hierarchically, and so it ends up looking like a family tree, hence the nomenclature, a tree structure. And then if it's a four-port switch, it might have one coming in and three going out, and then it looks like a chicken's foot, hence the name chicken foot. But I think I don't know if that's
Hmm.
terminology that we only use or few people use, but it's just to mean how you look at them hierarchically.
Okay, understood. Thanks for that clarification. So, when now when you've got at some point, when you're looking at what you have installed, you're going to have some sort of topology of some type. But I know historically, a lot of these networks have grown in a very ad hoc way over time, just connecting one thing to the next to get everything talking. So considering that a lot of industrial networks are have been developed that way, how can you assess what you have in place with an idea towards determining what the best topology type you should have for your existing application, in case you want to revisit it for optimal performance or positioning it for future growth or what have you? How can you assess what you have and versus what you should have?
Yeah, there are a number of commercially available tools, and there might even be some open source tools, particularly for Ethernet networks. Again, because Ethernet is so widely used in the commercial office environment and residential, consumer environment, that a lot of these tools have just come out onto the market, and since many industrial Ethernet protocols, including Profinet, is based on using standard unmodified Ethernet, you can use those tools in your industrial Ethernet networks. But to talk about field buses, I think that the the commercially available tools available to look at them for field buses are really great, because what you can do is you can plug them into your network, and what they do is they go out and they find all of the, in this case, for example, Profibus devices on a network, and they draw all the lines, they look at all the devices that are out there, and they really just create you with something like a map. And then you can say, oh, I've got this device here, it's connected to this device, and so on and so forth. And when you talk about how networks have evolved over time, I think it's a little less likely with field buses than with than with Ethernet, because if somebody's looking at a Fieldbus network and they see that DB9 connector, in this day and age, it's not likely that somebody's going to go over there and try and plug something into it like a laptop or a printer or whatever the case may be. Whereas I think with Ethernet, the thing that you point out is more common. Somebody sees an Ethernet port, they don't realize that it's their industrial Ethernet network, and they go in and they just plug in their old, whatever they've got in their hand because they want to connect to something somewhere else, and that can sometimes cause problems, particularly when it relates to bandwidth. And so, when we talk about networks that have evolved over time, in a field bus network, you don't really have to worry about that too much because it's a closed network. Whereas Ethernet, again, if we're using standard Ethernet and not doing anything to it, multiple protocols can run on the same wire. And so when you have that's a great benefit. That's a beautiful thing, especially when we start talking about the industrial Internet of Things and Industry 4.0 and all these topics, because you want to use the right tool for the right task and the right protocol for the right job. So somebody's going to start using. They set up their industrial network, and then, oh well, not only do we want to use our industrial Ethernet protocol, we also want to start using some other protocol, whether it's HTTP for a web server or whether it's OPC to connect via to an HMI or something like this. And at this point, then you start utilizing different links within your topology more and more. And so how these networks evolve is you see bandwidth utilization on a given link go up and up and up. And that's where you can really sometimes run into trouble to if you start using up 90 or even 70 or percentage of your bandwidth if your bandwidth utilization goes high. And so some ways to mitigate that, some Ethernet switches, for example, support a feature called trunking. In trunking, what that allows you to do is not only do you have one switch connected to another switch via 100 megabit per second, for example, but if both switches support trunking, then you can just run another wire from, let's say, another port on that switch to to a port on the other switch, and now they know that, and they'll call that link a 200 megabit per second trunk. And so now you've just doubled the available bandwidth on a given link. If maybe that particular link had a lot of devices connected to it at the other end and the utilization was getting very high. So that's one strategy that people use to edit their networks and allow them to handle changes that have come over time. Some other people will set up a backbone. So they'll set up a gigabit or 10 gigabit backbone. Certain ports on the switches at a higher level will have that functionality, and they'll set up a big 10 gigabit backbone across a line or something like this, and then drop lines off of it, individual lines at 100 megabits per second. And those are different ways that you can mitigate it. And in some case, if there's a particular line that has too much usage on it, they'll stick in a switch and then run a wire in parallel to that line that just takes some of the bandwidth off of it and frees up some bandwidth that way. So there are a lot of things that you can do to mitigate the issue with Ethernet, because again, these networks have evolved, I think, a lot more readily than, let's say, classical field buses, where since it was a closed network, you didn't see really people jumping on to the network that weren't supposed to be there, or if they did add devices to it, then they did so very carefully. I think than more so with Ethernet.
In your response there, you mentioned designing these networks and setting them up for industrial Internet of Things or Industry 4.0, and given that a lot of companies at this stage in the game are still assessing that and figuring out how much of this they're going to do or how and when they're going to do it, and as part of a just a very simple effort or as part of a bigger digital transformation, if you will. What's the best way? We talked about there how to assess what you have and determine if it's right for what you got. But what about looking forward with an idea of not knowing necessarily what exactly is going to come next or what's going to be required of you in the next, say, 3 to 5 years in terms of connectivity to other plants, to companies you supply, what have you? With that in mind, is there a way to assess where you're at and position yourself for that type of growth so that your network can be able to grow with those new sorts of requirements, and so you don't have to totally reorchestrate it from the ground up?
Yeah, I think there are a couple of things you can do. From a if this is specifically about topology, not necessarily, because and I'll explain why in a second. The answer really, if you want to position yourself for the future, simply bet on Ethernet. Just just bet on it
Mm.
now and assume that that is going to be the backbone for your network, because if we've seen anything at this point, we know that it's here and it's here to stay, and and the flexibility of Ethernet is really really great in that it doesn't limit you to a particular type of topology, and that's what I was getting at the beginning of my answer. Because Ethernet is so flexible with rings and lines and stars, if you bet on Ethernet, then if changes do come along, then you have the flexibility to put a switch in there or do something like trunking or do something to alleviate any issues. That being said, there are some pretty cool things that the pretty cool advances that are coming to Ethernet that will almost make it even more future proof if you don't even want to try and consider whether you're going to install 1 gigabit, 10 gigabit, 100 megabit per second Ethernet. And I don't know if this is the time and place to talk about things like time sensitive networking or TSN, but I would say if you're gonna plan for the future, bet one, bet on Ethernet. Bet number two, bet that in the future, like I said before, there are going to be multiple protocols running on the same wire. And so therefore, you want to right now plan to have as much possible bandwidth as you can. So if you are able to, install gigabit wiring now, even if you're not even using a measurable percentage of the bandwidth, just plan that down the line these things are going to happen, because people are going to want to even more and more get from that IT level down to that OT level. And if you have Ethernet as far as you possibly can go, then you can get that data. And then what does that mean? Well, that data is using up more and more bandwidth. So that's what I would say. Bet on Ethernet and bet on as much bandwidth as you can install possibly today with an eye towards future utilization of it.
So we've covered a lot of ground here today, Michael. With that, and you brought up time-sensitive networking, which is definitely a topic we'll be digging into in a future podcast. But that is definitely a topic unto itself. But with that in mind, with looking at all we've covered today and explaining the different topologies and the different types of networks and assessing what you have and looking, towards future options for implementation or for various applications that you have. Anything else you'd like to add that end users should be aware of when it comes to assessing their networks and the topologies they might be using?
No, I would say generally, as we make the transition from Fieldbus based networks to Ethernet based networks, I think many users are going to find that they'll be relieved with the flexibility that they have when they do that. And so there are tools called gateways or proxies that make that transition easier, so that you can do a piecewise migration. And then the flexibility of Ethernet really gets in there to allow you to set up your topology for a given part of the line, maybe that has transferred to Ethernet, while another part sits in your traditional field bus, and then move piece by piece, because we don't expect people to rip and replace everything. That just doesn't make any sense, either financially or logically. And so by using different gateways, you can bring that field bus data into your wider Ethernet network, and then leverage the flexibility of Ethernet and its flexible topologies to get that data where it needs to go.
All right. Well, thanks for joining me for this podcast, Michael. And to all of our listeners, please keep watching this space for the next installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.